6.4 deals with dilations. And a dilation is an enlargement or a reduction of an image by a scale factor k. So when you see a k, they're saying k equals some number, and that's the scale factor. Okay, scale factor is how big we make it or how small we make it. So this is an example. So we have this original triangle ABC, and we made this one bigger, so this is an enlargement. Okay, the symbols, this k right here, kx, comma, ky, that's the scale. So if it was like, if it increased by times 3, then there'd be a 3 there. Okay, so we will get the same shape, but not the same size. Does anyone else know what would be the same other than the shape? There's something else that would be the same. The letters. Yes. Anything else that's the same from here to here?
Place.
Not the place. Anyone else see anything inside the triangle? It's imaginary. Hannah? The amount of space? No. Not volume. You guys are still waking up, aren't you? What do triangles have? What do triangles have?
I know.
What?
Angle.
Good, thank you. So they all have the same angle. Okay, so we're going to change the size, not the shape, and not the angles. And that deals with congruency. Okay, Chapter 7, we're going to look at congruent angles. So that's where we're going. Okay. We're going to look at some examples in the book. So turn to page 490 and 491. If you don't have your book, you'll have to do this on graph paper, so hopefully you have a book. Okay, so 490, 1 and 2, and 491, 1 and 2. And I'm still going to record this so people at home can have this information. Okay. So, first we need to graph this triangle right here. So go to 3, 5, and put your A, and then 0, 4, and that's B, and then we have negative 2, and that's C. Okay, so you should have a triangle like that, right? And now it says K equals 2. K is our scale factor, so this is really easy. You take every number and multiply it by 2. Okay, so now A prime is going to be 6, 10. Multiply everything by 2. B prime is 0, 8. And C prime is negative 4, negative 4. Okay, now we graph these points. Is it going to get bigger or smaller? Bigger. So this is an enlargement because we multiplied by 2. Okay? So go to 610. And that's your new A prime. And 0, 8 is your B prime. And then C prime, negative 4, negative 4. So what you should get is the same shape, just bigger. It's okay if the lines aren't straight. If it bothers you, you can use a ruler, a straight edge, or a protractor. But okay, so raise your hand if you can tell me what job in the real world, because I know Tyson likes to know. What job in the real world they use this like every day? Desi?
Construct.
Yeah. What would they look at that would be smaller? Do you know what it's called? Or a blueprint. Thanks. So blueprint, right? Blueprint, it's just a smaller version. Okay, so when they're building a house or building or anything, they have this on paper. Okay, it's also in a computer right now. But they look at the blueprints, and that tells them, like, maybe it's in centimeters or inches, and then they have to convert it to feet, right? Any other jobs where they use this? Any other, can you think of any technology or Tyson?
Well, I don't know anyone, but what if we're not going to be an instructor?
If you're not going to be a constructor,
Yeah.
you mean a construction worker?
Yeah.
Okay, well, could you think of another job you would use this then? No. Anyone else? Chris?
A painter?
A painter. How so?
When they're drawing like murals on building walls.
Uh-huh. Yeah, so they have their paper design, right? They kind of have a sketch, and then they go and they put that into something big. Or have you guys seen in the old-fashioned days? You're probably old enough to see projectors that are not like this projector. Remember the overhead projectors that was like a glass box?
Oh, yeah.
Okay.
They're good.
And so they would put a small thing up, and we did this in art when I was in school. And they'd put something small and then put it on a huge wall so we could paint it. That was kind of fun. Any other things you can think of? Yeah.
A math teacher.
Yeah, clearly a math teacher. That's a given. Any other jobs? Or any other technology? You guys probably don't do this so much anymore, but we used to have film in our cameras. Have you heard of this stuff?
Yeah, they do that.
Yeah.
In high school.
Yeah, they still develop it there. So film is a good example because you're taking a negative, it's called a negative, and you're enlarging it. Okay, you're blowing that up. You could blow up posters as well. So like we have this thing at the teacher center called the Super Zoomer. It's really fun. You put a small thing in and then it prints a big poster. It's true. What about anything, oh, you have one more?
Oh, I was gonna ask, what about those people that like make the sets for like plays and stuff?
Yeah, like a little model, and then yeah, anything like that. What about things that we make that start big and then we make them smaller? Is there anything like that we do?
Cars and toy cars.
Okay, yeah, maybe we have like a regular car and then they make a toy. So toy maker would make something smaller. Anything else that we make smaller all the time?
Phones.
Phones?
Snack size food.
No, they make them bigger.
What?
Maybe like you have a model car.
That's what she said? Anything else?
Phones used to be like
Okay, we might think of them,
big.
but let's do this one. Let's do this one. Ready? So we're going to graph number 2. So we have 0, negative 4. That would be here. That's J. And then 0, 6 would be here. So that's K. And then 4, 4 is L. And 4, 2.
This isn't a triangle.
It's not a triangle. I'm glad you noticed. What is it?
It's a trapezoid.
Is it a trapezoid?
Looks like it.
Yeah. You don't really have to draw this line, do you? It's just a quadrilateral, right? But yeah, it looks like a trapezoid. Okay, now see this K is 1/4. It's less than 1. So anytime you get K equals something less than 1, it's going smaller. It's going to be smaller. Greater than 1, bigger. So if it's at 1, does it change?
No.
No. And we call that, there's an actual term we use for if it's at 1. And you might have heard it in science because you're studying like kinetic energy and stuff like that. But it actually is called isometric. So if something doesn't change, it's like an isolated metric, that's where it comes from, then that's just a scale factor of 1. And that might come up on your test. So just keep in mind, if you see that word, it just means it doesn't change. All right, so let's go ahead and figure out, how do we figure out, we know it's going to be smaller, we need the new coordinates. So we take the 1/4, and you could multiply it through, or you could just divide by 4. Dividing by 4 is pretty easy, right? So what's J prime? What's 0 divided by 4? 0. And negative 4 divided by 4? Negative 1. K prime, we're going to have 0 and 6 divided by 4. Anyone know what that would be as a decimal or as a fraction? 6 over 4 is 3 over 2, right? So that's just 1.5. And then L is going to be easy. That's 1, 1, right? And then M is 1. And then what's 2 over 4? What does that simplify to?
1/2.
Yeah, 1/2. 2 over 4 is 1/2. So you could put 1/2 or 0.5. It doesn't matter. Okay, so now let's draw this. So j is 0, -1. So that's j prime. K is 0, 1.5. So go right about there. Halfway between 1 and 2. And then we have L is 1, 1. L prime. And M prime is 1, 1.5. Right? Oops, or sorry, 1.5, not 1.5. So it's like right there. They're really close together. Now when we connect the dots, we should get the same type of figure, just smaller, right? Okay, so while I was doing that, did anybody else think of anything where something gets smaller in the real world, other than toys and maybe clay modeling? Or
When you get older.
food?
Yeah. A lot smaller.
Food can get smaller, like
As you
Carissa
take
said, like
bites.
snack size food now. They've created like all these little like little ones. So maybe food people that create different foods. Maybe they think of smaller things. What else? People, but I'm thinking more of like a scale, like that we could measure it on. Yeah. Yeah, my refrigerator's pretty small. Okay, so what you guys are going to do is on the next page, you're going to do 1 and 2, okay? And you're going to try to do these by yourself.